The DAO was a system of smart contracts on the Ethereum blockchain that investors put millions of dollars into. Back in May 2016, it was the largest crowdfunding event in history, and we discussed it in detail in a previous episode with Matt Leising. The DAO was hacked due to a security vulnerability, and this event led to a hard fork of Ethereum. The DAO was organized by a company called Slock.it. Slock.it's original goal was to allow people to connect devices to the Ethereum blockchain. If you could connect smart locks and cars and electricity systems to the blockchain, it could create decentralized systems for sharing these devices. To raise money, Slock.it created the DAO. Although the initial scope of the DAO was to raise money for Slock.it, over time it expanded in scope to become a decentralized venture capital system. When the DAO was hacked, the events that followed shook the Ethereum community. The hard fork lowered the financial damage inflicted on the investors, but there was still outrage within the community of Ethereum. How was it possible for an open source crowdfunding project to launch with a security vulnerability like this? As the Ethereum world looked for someone to blame, they turned to Slock.it. Thus began a very difficult period in the life of Christoph Jentzsch. Christoph is the CEO of Slock.it, and he has been involved in the Ethereum community since the early days. When people think of Slock.it, they might imagine a group of people that move fast and break things. But in fact, Christoph's early work on Ethereum was around rigorous unit testing of different Ethereum clients. Christoph was obsessed with testing and consistency between the different Ethereum interfaces. In today's episode, Christoph and I talk about his early experiences with Ethereum, his reflections on the events of the DAO, and the direction that Slock.it is going today. Since the events of the DAO, the company has refocused its efforts on the original mission to connect devices to the Ethereum blockchain. Meetups for Software Engineering Daily are being planned, and you can go to softwareengineeringdaily.com/meetup if you want to register. We've got upcoming ones in New York, Boston, and LA. All the information is on softwareengineeringdaily.com/meetup. And if you're looking for our old episodes of Software Engineering Daily, all 700 episodes are in our apps on the iOS and Android App Store. You can find categories of different episodes like blockchains and business and distributed systems. We've got lots of other topics and a great search engine over all of our episodes. And if you want to become a paid subscriber to Software Engineering Daily, you can hear all of our episodes without advertisements. You can subscribe at softwaredaily.com, and all of the code for our apps is open source. So if you're looking for an open source community to be a part of, come check it out at github.com/softwareengineeringdaily. Thanks for being a listener, and let's get on with this episode. This episode of Software Engineering Daily is sponsored by Datadog. With automated monitoring, distributed tracing, and logging, Datadog provides deep end-to-end visibility into the health and performance of modern applications. Build rich dashboards, set alerts to identify anomalies, and collaborate with your team to troubleshoot and fix issues fast. Try it yourself by starting a free 14-day trial today. Listeners of this podcast will also receive a free Datadog t-shirt at softwareengineeringdaily.com/Datadog. That's softwareengineeringdaily.com/Datadog. Christoph Jentzsch is the CEO of Slock.it. Christoph, welcome to Software Engineering Daily.
Thank you very much.
Today we're going to talk about your background in Ethereum and Slock.it itself. But let's start with that background. When did you start working on Ethereum?
I started in summer 2014. That's when so actually right after the crowd sale.
Okay. And what were you doing in those early days? Were you just an investor, or did you get involved as a developer?
No, I was 100% developer. So my background is I'm a theoretical physicist. That's what I studied. I was doing my PhD and was doing software freelancing to get some extra money. And I was following Bitcoin since, I think, 2013, summer 2013. Then in January 2014, I found out about Ethereum, read everything about it. And then Gavin Wood gave a talk where he said in the end that they're looking for C++ developers in Berlin, and this is not too far from where I live. And so I applied. He said yes. And since then, I was working more or less full-time for Ethereum. And I was focusing on the testing. So you could say I was trying to prevent as many hard forks as possible when it comes to consensus between the different clients. So my first task was to study the yellow paper, especially the Ethereum virtual machine, and then write literally thousands of tests in a JSON format for every client to check if they are true to the protocol. So every single thing you can do within the Ethereum virtual machine, I was writing EVM bytecode, and then the Go client, the Python client, and the C++ client, and the Java client. Those were the clients which existed back then. They would run my tests to see if they are in consensus. And sometimes one of them would fail a test, and then I would have to explain to developers what I think they did wrong because they got a different result than the other clients did get with the same transaction. And so I was just trying to find differences between those clients and also trying to help to make the specification, the yellow paper, more clear. When I found something to be undefined, we need to define it. And that's for simple things as dividing by 0 or just doing a division with signed integers. You get a different result in Python than you get in C++ if you do signed integer divisions. And so it's just such things you discover in those tests, and then you need to specify it in the yellow paper. And once it's specified, you have clear tests, then it's fine. So this was my main job, and I worked really full-time developing and writing tests and finding bugs in the C++ client and also writing part of the C++ client. And the last thing I did was writing the specification for Ethash, the mining algorithm of C++. So I didn't come up with the algorithm. This was not my job. But after it was done, specifying it in the yellow paper and writing this last part, this was one of my last jobs before I left and did Slock.it.
You were doing QA testing on Ethereum. And I think that's amazing because people look at Ethereum and they're like, oh, it's this amazing world computer project. I think people probably don't think about as much the fact that there are developers plugging away at it, writing QA tests to verify that the Go client and the Python client are coming to the same conclusion.
This was a lot of work. I mean, in the beginning, they were not syncing at all. Like, we have to figure out why they were not coming to the same conclusions. Always you have a different hash of the state. So it took a while until they were again syncing the same test chain. And then it took a month until they all passed all my tests. And then I needed to add, of course, new tests, which were covering some edge cases where I thought that some clients may be messing it up because it was not really specified in yellow paper. So it's very implementation specific. And then what was also a lot of fun, which I introduced fuzz testing to Ethereum, which they still do today. And actually they were still finding stuff where we had about 100 cores in the EWS node. And I was more or less randomly creating certain types of transactions and throwing them at the Go client, C++ client, and Python client, and also Java client, and see if they always get the same result. And we found a lot of issues through fuzz testing. And this is something which they have now refined and are doing even better, because in the beginning, I was just, if you have completely random fuzz testing, you get almost no results. So you need to specify to make at least transaction which makes some kind of sense. But then you start finding things, and that's something, that's a way how they still find consensus issue today in the test group of Ethereum by doing a lot of fuzz testing.
I know you mentioned the divide by 0 or the division error that you had a test where there was some division that resulted in different results from the Go client versus the Python client, I think you said, or C++ client. What were some of the other reasons why you would have different results between different clients? And just to clarify for people, when we're talking about clients, what we're talking about is when people are using Ethereum nodes that are written in different languages, right? Like these are, whether you're talking about a wallet or you're talking about a mining node, these are different types of nodes, but different nodes that are running software that interfaces with the Ethereum blockchain. You want them to recognize transactions. You want them to when they process the transactions, the ordered set of transactions across the world computer, which they all are processing the same set of transactions, so it's very important that they all come to the same conclusion. That's what you're talking about here.
Exactly, and it's different from Bitcoin. Bitcoin didn't have a written specification. They just had a implementation, which was the C++ client, which is a reference client. So you have the specification written in code, so to say. For Ethereum, one of the main accomplishments, and I have to give a lot of credit to Gavin Wood here, who wrote a technical specification, which was the yellow paper, which was extremely important to specify what Ethereum actually is. And some of the things you can find, just very simple when you think about it, but you don't think about it when you write code, one is the call stack depth. Meaning, if you call one function into another function, into another function, into another function, and so on, each machine has a different parameter set as a maximum call stack depth. And so you could write a smart contract, which calls another contract, which calls another contract. And depending on your machine, depending on the compiler and different things, it would fail at a different level. And of course, this cannot be because they all need to fail at the same level. So then because of this, we have to introduce the 1024 call stack depth limit. This was one thing which we introduced after we found this issue, so that a transaction just fail after calling into another function more than 1024 times. This was one issue. So the signed integer division was one issue. Then we had one issue which actually led to a hard fork in the very early days of Ethereum, meaning summer 2015 was 2 weeks after the blockchain was launched, and Go client, C++ client, and the Python client were live. And then we found in the German time, it was in the evening, about 8 or 9 o'clock, there was a hard fork. Like the Go client and C++ client were not going on the same chain anymore. And so they were basically calling me, let's look at what's happening. We were in an emergency group, in the Skype group. And then it was for me to find out, this is the transaction. Okay, now I look at the EVM code. Now I look at the trace, like what's happening in the EVM with each transaction, what happens in the Go clients, what happens in C++ client. Then we found the difference was there was part of memory set to a certain non-zero values. Then it was making a call which was supposed to write into this memory. And in the one client, it was writing, nothing was coming back, but one client was interpreting it as writing zeros, the other one as leaving it as is. So then no data came back. So C++, I think, said, don't change it. And Go said, change it to 0 then. And this was the difference. So it took about 2 or 3 hours to find it. Then after we found it, I wrote a test for it. Then with the test, the Go implementers could see, okay, I know what we are doing wrong. According to the protocol, Go was wrong, C++ was right. And then they had to change it. Although they were the majority of the chain, you could say, well, 90% of the network is running, or even 95% is running the Go client. Only 5% is C++ client. So we could have just said, let's just fix the minority clients, because it's really doesn't matter. We just specified in the specification, in yellow paper, and then fix the C++ client. But we were very strict about this. We have a specification. It doesn't matter if it's a maturity client or not. The one who makes the error or a bug, he has to fix it. So we fixed the Go client. Back then, we could just call the miner saying, well, there's a bug. They just updated, and within a couple, 6 or 7 hours, everything was fine again, and people didn't even notice. So this was like the first hard fork, and people didn't pay any attention to it. It was nobody in the news. Nobody looked at it because it was fixed within hours. And you could still, that the community was so small that you could communicate very quickly. And this was one of those experiences where I was there to basically see what is going wrong. Why do we have different results in different clients?
This community within Ethereum has changed a lot since 2014. It's grown. How have you seen the community change? What have been the notable changes since you joined the community?
It changed a lot, I have to say. I mean, in the beginning, you have visionaries who just want to build the Web 3.0. So I was really attracted by Ethereum for the whole Web 3.0 mission, the decentralized internet, especially the whole smart contract thing. And so you had those people who, they did make a lot of money, but they didn't came for the money. They came for something, they take a huge risk because nobody did really know if this would work out or not. After it was launched, of course, you have more speculators coming into the game, early adopters, people looking into this new technology. And back then, and still today, but back then much, much more, we had this strict we could say, ideology of being 100% decentralized with no governance at all. And so this is also where the DAO was born, out of this idea. And if you look at the early Ethereum projects like Augur was one of the first ones. They also did a crowd sale, but their intent was always to build something where they could walk away afterwards and would function forever, like Bitcoin, like Ethereum. And so they intended the same for Augur. This was the same thought behind the DAO that we also were heavily involved in. And so then after this failed, the DAO project, and we had this long story, which is maybe something for another episode. I could speak for hours about the whole DAO incident. But then people moved into ICOs, which were much more centralized, and out for security reasons, that people said, well, even though purely decentralized governance doesn't really work, it's too dangerous. And so let's just do an ICO where we just get all the money and then people hope for the best and we do something with it. So we lost a lot of this purely decentralized ideology of building something which just is there forever, like a protocol. Something you build once, then you move away, it just is there. It just exists. And that's something I miss a little bit, but I also see now in the last months or years coming back a lot of the governance questions that people try to build, like what Vitali called DAICOs or Colony or Aragon. They're doing a lot of this direction of having governance on the blockchain and defined governance. So you still have those people who dream of this new form of a society and decentralized governance. And you, of course, also have all those speculators who just try to make a quick buck. But also you now have, since maybe it started a lot with Microsoft at DEFCON 1, I think it was, when they joined at the Ethereum movement, if you want, and that big industrial players and corporates taking interest in Ethereum. And this of course, meant a lot for Ethereum because now much more money was flowing in, much more developers from large corporates were interested in Ethereum. And you see today, for example, the Ethereum Enterprise Alliance and others who are focusing on use cases where decentralization is maybe not the key issue or the key point, but maybe more automation of business contracts and other things. So it was started more as a movement, ideology, an idea, and moved more into a neutral technology which you can use for different things, which is fine too. But I still think the core Ethereum community exists and is still very active. It's just that the expectations have increased by a huge amount, and now other problems such as scalability are issues, and of course governance is still an issue to some extent. So yes, we have seen some changes, but I wouldn't see them necessarily completely bad. We just have grown so big that now a lot of different groups and communities belong to the bigger Ethereum group, the corporates, the anarchists, the banks, the military. I just remember one fun session. I was in California, I think it was 2015, to a blockchain conference, about 30 people there. And you had those people there, those punks with the laptops, destroy the banks and anarchy. And then you had people from the banks there, and you had investors there. And you had some people from the military because they're thinking about how can we use blockchain for military stuff. And you just had such a diverse group there. And I was thinking about how great this technology is to bring together this kind of diverse group and how they all see a use case in it. And I think all those groups still exist. We just have expanded and grown by a lot.
Software Engineering Daily is brought to you by ConsenSys. Do you think blockchain technology is only used for cryptocurrency? Think again. ConsenSys develops tools and infrastructure to enable a decentralized future built on Ethereum, the most advanced blockchain development platform. ConsenSys has hundreds of Web3 developers that are building decentralized applications, focusing on world-changing ideas like creating a system for self-sovereign identity, managing supply chains, developing a more efficient electricity provider, and much more. So, listeners, why continue to build the internet of today when you can build the internet of the future on the blockchain? ConsenSys is actively hiring talented software developers to help build the decentralized web. Learn more about ConsenSys projects and open source jobs at consensys.net/sedaily. That's consensys.net/sedaily. Consensys.net/sedaily. Thanks again, ConsenSys. It sure is interesting that some of the people look at Ethereum and they see basically a way to have a shared database, and they're excited about, like, we can just have a shared database. Like, that's all it really is to them. But that notion is powerful enough that they want to use it. Like, that's but then of course there are the decentralized anarchist type people who are still in the community who have much bigger ambitions, who want to have a decentralized autonomous Uber and a decentralized autonomous Airbnb or a decentralized autonomous Amazon. Like, I think the technology for having a shared database that, if somebody wants to verify their soybean supply chain, we pretty much have the tech for that today. I think the implementation can be carried out by various consulting groups and so on. But I think that the more exciting technological developments to discuss are what we need to get to have these decentralized apps like the decentralized Uber or the decentralized Airbnb or decentralized Google. What do we need in order to get to that world? Is it sharding? Is it something like Plasma? What are the basic fundamental technological breakthroughs that Ethereum needs to make in order to have high throughput, mass adoption, everyday people using smart contracts and apps behind the scenes?
Many things. Of course, you mentioned scalability. And this is, of course, right now, the main problem and focus. And I think you already spoke with other people about this. And yes, Plasma is a nice solution. I really love state channels and what L4 is doing. Also Raiden doing payment channels. This is interesting off-chain solutions that I think all of this is very, very important and absolute key. Before we see any mass adoption, we need huge progress on this side of scalability. And of course, sharding is also one solution. I think they will all go hand in hand with each other depending on the application. So this is the one side of things, getting the basic infrastructure ready. But now the other question is a bit bigger. If you think about, you want to have autonomous objects, and it's also now we're getting a little bit into Slock.it, and to how can we move into this world? And one main thing is, Ethereum is also a PKI, so public key infrastructure system, and we need people and objects to manage their keys. And this is hard because they need to store them securely. They need to feel responsible for them. They need to understand what it means to hold their private keys. And with those private keys, they interact with every system. And if we get this, there will never ever be a lock-in into a system like Google or Amazon or whatever service you use. You just have your key. You have multiple keys for different things you use. And those keys can, on a blockchain, or especially public Ethereum chain, interact with another thing on this level. So you can interact with a machine because the machine can also hold the key. Permissions to use something can be stored in a smart contract. Because if you really think about, you said a shared database, this is true, but blockchain is more than a shared database. And I have really thought a lot about this in the last years when I saw applications. I have tons of workshops about people saying, what can we use blockchain for? And one thing what it really is, it manages permissions, especially smart contracts. They say who is allowed to do what. It can be financial transactions, like in Bitcoin, it's just who's allowed to spend how much Bitcoins. In Ethereum, it's also who's allowed to spend how much Ether, under which conditions, which are defined in a smart contract. So we have programmable money. But even more important for us as Slock.it is, you can say devices can now have something like digital cash. And they can say, I manage my permissions on a smart contract, and only the smart contract is telling me who's allowed to use me. And this can be based on simple payment. It can be based on some keys having authority to say who's allowed to use me or use me directly. And this is my highest authority of who can use me. And this could be a car, this could be an apartment through a smart door lock or other things. And then on the other side, the user side, it just sent a signed message, which can come over any protocol like Bluetooth, Wi-Fi, whatever. And they just say, I want to use you, please open or give me access. And they then look at the blockchain and see if he's allowed to do so or not. So, and in this world, objects as well as people or corporates need to manage their own keys. And I think public key infrastructure with a very good private key management, this will be key to adoption. And once we get there, that everyone has a couple of keys in their phone, knows about them, knows how to manage them, and feels responsible for them, then they can really use this infrastructure. The third thing is, of course, you need to have a connectivity to the blockchain. Right now, this means running at least a light client. And this is already, so you can do it with a smartphone, but it really brings it to its limit when it comes to how much CPU power you're using, but especially bandwidth. If you're running a light client constantly, you need so much bandwidth, it becomes unfeasible for IoT objects or for cars or other things in this direction. So we also need a solution how to securely connect devices to the blockchain, and not people just using my crypto or my Ether wallet or something in this direction where I just have a browser, which is already nice, but you still rely on some node to send it to. It's not a direct connection to the blockchain. But people do it because it's such a burden to run their own client. So we need to improve light clients, or parity said thin clients, and Slock.it is also working on a solution in this direction, how to securely connect IoT devices without any single point of failures. But those are, I think, the three main issues. So to summarize, it's scalability for mass adoption, it's managing of private keys, and its connection to the blockchain in a secure and decentralized way without needing a lot of bandwidth and storage and computational power.
You talked about some use cases there. The registering of Internet of Things objects, maybe connected bicycles or the lock to my home. Do I want to, who has permission to unlock, like let's say we had a biometric lock where you just put your thumbprint on my lock and you can open my door. Who has permission to enter my home? Maybe if I'm trying to run a decentralized autonomous Airbnb, it's very useful to have these biometric locks with a decentralized permission system. But for most organizations, the systems that they would want to use to manage permissioning and public key infrastructure, it seems like those things could be centralized. Why wouldn't they just use AWS or Google Cloud? Do you have a set of rules for what kinds of applications would make sense to port to decentralized infrastructure? Like if we're really being serious here, what are the apps that people need decentralized infrastructure for versus ones where, yeah, it's kind of exciting, but probably it just makes more sense to put things in AWS? Yeah,
that's a very good point. The answer is, of course, first, everything where you want to remove any single point of failure, and also censorship resistance, if you need this. But for many cases, the simple stuff, you just don't need censorship resistance, or you also don't need to avoid a single point of failure. But if you have those, then decentralization is basically a must. On the other hand, sometimes people ask me, why just not use this SQL database by using a blockchain? I sometimes feel there are certain applications where it's even easier to build on top of a blockchain than to just use AWS, because the blockchain automatically gives you a PKI system. It gives you a securely managed backbone, which has zero downtime, which is always up, which doesn't require any logins and those kind of things. So it's sometimes even faster to just use this without building your own service system, which you need to secure through a firewall and whatever means you need to protect the data. Here you say, I don't need to protect the data because I don't have the data, because the people hold their own data. So if you want to move into this world where you have no logins, people hold their own data, then also a decentralized way of managing this is very important. But I also have, so in my mind, I've moved also a lot from having everything decentralized, because I believe there are a lot of things that just doesn't make sense. In the IoT world, there you have this problem of things should be there for 20, 30, or 40 years. If you buy a car, it should work without touching any of the inner workings for like 20 years or so. So meaning even if the manufacturer doesn't exist anymore. If you buy a light bulb with LEDs, technically there's no problem on lasting for 20 years or so. But the company having produced it doesn't want to have a server infrastructure which your light bulb can always connect to and manage it for dozens of years. So when you think about long-term stability, you also want to have something where you have no server infrastructure or no single point of failure. This is why I think for IoT applications, there are some where it makes a lot of sense to use this something more like a protocol. I often say Ethereum is just a protocol. Like email, you have SMTP and you have other protocols, and they just exist and they don't stop existing. And as long as it's working, your device is working. So it becomes a part of the device itself to be able to do certain things. So I sometimes compare to, if you have a smart lock and we connect it to the blockchain, then you give the lock itself the ability to be controlled or used via the blockchain or via a payment, for example. Before, when you buy a lock, you don't care if the manufacturer exists or not. You know, I have a key, I can use it with a key. That's a feature of the lock itself. And by connecting it to the blockchain, I say it's a feature of the lock itself that can open it via a payment. If I do this with centralized cloud, then it's not a feature of the lock itself. It's a feature which is given the lock by a third party, as long as the third party exists. So it's a different value proposition. And if you want to have something where the feature is within the device or within the service, then you need to connect to something which more or less exists forever, or at least for a very long time.
You started Slock.it with a couple other co-founders. What was the original vision of Slock.it?
To connect all smart devices to the blockchain and control it via a smart contract in order to enable a decentralized sharing economy. This was now a long sentence. So, meaning, if you want to rent out something, all you need to do is lock this thing with a smart device. Could be a smart power plug, a smart padlock, a smart bike lock, a smart door lock, or whatever else you can control in a smart way. Smart meaning just connected to the internet somehow. You just lock it, and then you're done. Then people can find it within the app because it's registered on the public Ethereum chain. They can pay for access. And when they are in front of it, they can also use the same app to access it. So, for example, you have a bike and you want to, you're away for 6 months for a trip, and you want to make some money with it. All you would have to do is buy a Slock.it powered bike lock, lock it, and then you're done. And people can use it for a while. When you come back, you look at your app and GPS, find your bike, you hope it's not broken, and can take it with you. And you did make some money on the way. So allowing people to share almost everything which you can somehow connect to the internet. This was, or still is, the original idea. And we are working hard on making this possible. We have a minimal viable product out where we didn't have made any buzz about it. You have no marketing or anything like this. But if you go on the website mvp.slock.it, you can register to become a test user and use the app already. It works right now for smart door locks and smart power plugs. So everything you can connect to it, you can register there. People can find it, book it, pay it, and access it in the same app.
I want to talk about the Internet of Things developments that you're working on at Slock.it. I did want to talk a little bit about the DAO first. So before your current efforts at Slock.it, you were working on the DAO project, and we did a whole show on the DAO, but I would love to get some reflections and conversations about that. Can you summarize what happened with the DAO?
Summarize is good. It failed. But, well, after we started Slock.it in November 2015, we thought about how to fund it. And, well, initial idea was doing something like a token sale or ICO, which was back then not as popular as it is today. We would be like the second or third company doing something like this. But when I programmed the ICO contract, I said, well, why not give the token holders more power? So I said, let's have them vote how we use the money. Then let's give them even more power. They can keep the money, and we ask for it. And if they vote for it, we get it. And then I said, well, let's open it for everyone. So everybody can ask for money and get it based on the token holder saying it. This was the origin of the DAO. So I wrote the smart contract, and then we stopped, basically released it version 1.0. Now everybody could deploy it to the blockchain or use it. This, of course, now a long story made very short. After this, you know the story, about $150 million went into the DAO smart contract, which I didn't feel very comfortable about because it was not was not designed to hold so much value, but we had back then about 5,000 or 6,000 Slack users. So if each of them would have given $1,000, we would have ended up with 5 or 6 million or something in this range. So we certainly did not expect anything like this. I mean, we did the best we could when it comes to security. I mean, this was back then where Solidity didn't even have compiler warnings. There was no debugger. There was nothing like this. So this was very, very early, and we had very good advisors. Also, all the main Ethereum founders or inventors, I showed the code and they had to look at it. So we gave it to a security audit company. We felt good with it. But of course, there was a bug. called the re-entrancy bug, which allowed a hacker to withdraw about $50 million into a so-called split DAO, so into another account, you could say, where the money was locked for more than 5 weeks. And this 5 weeks now was time to do something. But since it was a really decentralized, autonomous organization, nobody had any control over it. And we could just look, and then we said, well, let's try for a soft fork where the miners at least buy us some time by censoring all the transactions which would go to the DAO, meaning stop it from operating. So nobody can restore any money, and we can think about what to do with it. But it turned out this would open up for a DOS exploit. So the soft fork was canceled, and then there was only one solution left, which was a hard fork. And here there was a vote going on the blockchain, but even there, I think about 5% of those who had Ether voted. So participation could be much higher, but wasn't. And so, but they voted like 80 or 90% in favor of a hard fork. The mining pools did have a vote, and also there you have about 80 to 90% voting in favor of a hard fork. So it's every sign we could have from the community, even on social media, every vote which was done was showing into a favor of the hard fork. That's why the developers of those clients have implemented it. Even there gave it as an option for users to choose in favor or against the DAO hard fork. And the real vote was people installing or updating their clients, because that's the only way you could do a hard fork. People who would do nothing would be against the hard fork. Only those who actively updated their clients or installed it or set some parameters on the command line, they would run the client which would run on the hard forked Ethereum chain. And the hard fork was basically just a rule where we created a new smart contract called Withdraw DAO contract, where all the money which had something to do with the DAO was going into, and people could exchange their DAO tokens for their Ether. So it was basically giving people their money back. There was still some edge cases where a group did look at explicitly, which was a bit more difficult. So thanks also for the white hat hackers who was very active and generous back in this time, or still are. So this was in short the story of the DAO. So it was a failed experiment in some sense, technically, because it failed because of a bug in the smart contract. It should have been a really interesting experiment in decentralized governance, because it did hold about 12 million Ether. So I don't want to think about how much the value of this is today. But with this the thinking of it was being something like a decentralized company. So where it would say it would order Slock.it to build those smart locks, where every time they were be used, there would be a profit for the DAO. Then they would ask a marketing company to do marketing for those locks. They would ask lawyers to look at a legal registration somewhere. There were even some Swiss lawyers who want to have a representation in Switzerland for the DAO. There was professional investors who would look at each proposal and make a report for it. So it was basically a group of people who would decide who to give money to for certain things. But when I started it, I thought of it as a decentralized sharing economy company. After so much money went into it, people thought of it as a decentralized investment fund. So this was just how they looked at it. And I myself didn't comment to it at all. So I kept myself quiet, because I said, I do not want to define what this thing is. That's why the name, the DAO, nobody gave the thing a name. I was asked for a name. I said, well, the DAO has to vote for its own name. I cannot say how this company should be named, because I just wrote a smart contract, and I'm more or less the lawyer preparing the contract which other people signed. So you had like about 15 or 20,000 founders creating a new company and then operating. If they give the money to charity, then it's a charity DAO. If they give the money to companies, it looks like a fund. If they use it for buying products and services, which they would market and sell it to someone else, then it's more like a company. So technically, it was just like a big joint bank account for many people had joint access and could only spend it together. And the rest is just history, how people perceived it. But of course, it was a very challenging situation for the Ethereum community when it comes to governance. So for the first time, we had a not technical hard fork, but a political hard fork, you could say. So it was good that we had this challenge early on and dealt with it. And we've felt the consequences. We learned how a political hard fork turns out, that you cannot kill the old chain. It will always exist, which people didn't really realize after it really happened. Of course, you could have thought about this before, and yes, people said it will happen, but many didn't believe it would happen. So it was a big learning experience when it comes to smart contract security. It was a personal learning experience about how not to do things and how to do things. But it was still a great experience after all, although an experience which had hurt a lot, but sometimes pain is the best way to grow.
I'll agree with that. I think it must be interesting. You started working on Ethereum doing this rigorous QA testing. So I'm sure it's in your DNA to be very sure that something functions before you put a lot of momentum and money behind it. And so it doesn't surprise me that you had some uncertainty when you were starting to roll out the DAO, perhaps before it had been thoroughly tested. Do you have any ideas for how you would test the smart contracts, or how you would build a smart contract testing pipeline if you could go back and you had to actually do the DAO in a way that would make sense?
It's a very hard question. The thing is, you cannot really know the unknown unknowns. Meaning, it's a bit of an irony that it happened to me as the one who being the main leader of testing in Ethereum. But on the other hand, I really can say, if we would have tested 2 or 3 times longer than we did, it wouldn't have changed anything. We wouldn't have found it, simply because we were not aware of it. So I have looked at this contract, which is about 600 lines of code. For a soft developer, this is really nothing. I have looked at it times and times and times again. Other people have looked at it, and we had experts. As I said, we had great advisors, that the ones who created Solidity, they are the ones who looked at our smart contract. But I will not blame them here. I mean, they were not paid for it. They just they did me a favor in looking at the contract for me. We paid one company who looked professionally at it. I was with them and said, if you find something, just tell me. And they didn't really find anything serious. So looking back, although it was this big failure, I really don't know what I should have changed, except of putting in a cap or saying start an experiment slowly and saying, well, let's just cap it with like 1 million, or let's say 100,000. Let's see if people can hack it. And on the other side, you should have seen me during this time. I was not comfortable with this whole situation. And it felt like the community was a vibe behind me and say, code faster, release. You had this community of about 6,000 people who just wanted this thing to start. And we have basically postponed it and postponed it and postponed it. And only because I said, I'm not ready, I'm not ready, I'm not ready. But everybody else was saying, this thing is ready since a month. We didn't change anything, just started. And so it was a difficult situation. Looking back at it, of course, testing it with a cap, this would have been, I think, the really only solution. But on the other hand, people said, if you put in a cap, then there's just one guy buying 1 million into it and it will not be decentralized. So today, the arguments are a bit different. Back then, people feared mostly for decentralization. So if we said, for example, we want to keep 5% and do something like security audit checks and stuff, they screamed online at us. You keep something? No, then it's not autonomous again. That's not decentralized. And so a cap was discussed in the Slack channel, but everybody was against it, or most of the people were against it, simply because people were fearing of, no, this is not decentralized. A couple of people get everything. No. And so I wanted to keep it as pure as possible. And to do a pure DAO, this was the only way to go. And the risk was high. That's why I didn't feel comfortable with it. But I did let people influence me and convince me of releasing. This was maybe my mistake, to not be stronger saying no. And after I released it, I just went on vacation and I was physically, mentally so stressed. I just couldn't look at Slack, online, Reddit, social media, anything. I was just quiet. And then when the DAO hack happened, I just had my hardest time of my life, I would say. But I'm very thankful. Like even now, maybe of course, Ethereum community is listening. Thank you again, Ethereum community, for basically saving the DAO by giving those people their money back, which was something I could not have done alone, which was their decision. So, but it was this experience I learned from, we as Slock.it learned from, the community learned from, everybody learned from, and now nobody really has done anything like this again. There are people calling themselves DAOs, but when I say it's a DAO, it means if there's anything I can remove and it doesn't work anymore, then it's not a DAO. And so this is something I have not seen until now.
If you love Software Engineering Daily, I think you'll also love the Google Cloud Platform podcast. It's a podcast about Google Cloud products, how they're built, and how you can use them. But really, it's all about the changes that are going on in software engineering, as told from the point of view of Google engineers. You can find the Google Cloud Platform podcast at gcppodcast.com. You'll hear from Googlers like Vint Cerf, and all about TensorFlow and Firebase and BigQuery, from the high-level use cases to the low-level implementation. The GCP podcast has all of that covered. Find the Google Cloud Platform podcast at gcppodcast.com and subscribe to it wherever you get your podcasts. This show is mostly about software engineering, but I've talked to a lot of different people who have started businesses that have had really bad problems at certain points, and they have really controversial problems that come up, and oftentimes, it results in the founder or the creator of the project going through a time of incredible pain, and obviously you grow because of that, but do you have any lessons or reflections from going through that super difficult time? Because I'm sure there's somebody out there that's listening right now that is going through something similar, probably not to the same financial scale, but it'll probably seem to them personally like they're going through something that is of that magnitude.
Now it's not technical, now it's personal. Very personal here. So I myself, this is of course not true for everybody, but I had two people in my life who I can always trust and which helped me through this time. One is God. I have a strong faith in him and he helped me through this time. And another one is my wife. And so they helped me mentally and physically to go through this time. And then, of course, when it comes now to, again, go to development and at the company level, you have founders team. We have been 3 people helping each other. And that's, of course, important that you trust each other. And if you have a clear vision, you just continue with persistency, hard work, and just move on. And but I'm not just moving on without taking lessons with you. But the good thing is every bad time has an end. There is even the DAO now, it's hard as it was. During the time you think like, no, this is written in the blockchain forever. This will be with me forever. And it could destroy Ethereum. I mean, this is like so big and this is like change everything. But looking now back at it, it's now more than 2 years. You see it as, well, it happened. Or no, not almost 2 years. And time heals wounds. You move on and you take lessons with you, such as taking care of security and doing things step by step. If I would do something like this again, I would say moving from centralization to decentralization step by step is a wise idea. But don't forget why you are doing it. You need a very good reason for the why in order to move on. And it cannot just be money, because this will not hold long enough. There are easier ways to make money.
I hear you. So after those events, you eventually pivoted the business to the Slock.it discussion that we had a little bit earlier about connected devices and IoT. So can you describe how the business runs today, like what your focus is on? Because I know you're building this IoT ecosystem. You're also doing some partnerships with various corporations. What are the steps that you're taking to accomplish those goals of making that IoT ecosystem?
Yeah, we went back to our roots. Like Slock.it started as a company connecting IoT devices, blockchain, was a bit distracted by the DAO, and now we are back to our roots. So we have about half of the company doing projects with large corporates where we connect their devices or things to the blockchain to enable their use case or business case. So we're working with Siemens, we're working with some companies in the automotive industry. And so this is one part of a business and it pays the bill, you could say, but it also is a lot of fun to doing those proof of concepts and helping those big corporates being very innovative and saying, how do we want to use the blockchain? The other part of the company is saying, we want to enable a sharing network. If we connect those things to the blockchain, this enables them to rent themselves out. They can ask for payment to be used. And so we have our app. We want to enable the sharing platform, but we also have to say we have not started doing any marketing yet. So I would say, as of today, we are focusing more on this, you could say IoT gateway. I don't know what is a good comparison. It's maybe if Stripe, a payment platform, a payment provider for platforms, which connects registered users to other registered users, and we are connecting humans to machines, machines to humans, and in the end, machines to machines. And we want to help companies and also private people, of course, to connect their device to the blockchain. This is the core mission, and we are doing a lot of different things for it. We are working with smart home gateways to get an integration there. We are also trying to we are getting cloud integrations for smart lock manufacturers to control their logs via the cloud, which is of course not decentralized. It still gets us closer to our vision of controlling devices via the blockchain, which can also still happen in the cloud. So everything which increases the number of devices which are controlled by the blockchain makes us more successful, having us more devices on our platform and being to service to corporates and private people.
So today you can do that to some degree on Ethereum. Like, is there the scalability bottlenecks that we talked about earlier? Does that inhibit the ability to build IoT connectivity on the Ethereum blockchain?
Yes, it does. Right now we are on the Coven testnet, and the main chat would just be too expensive for our use case. So that's why in the beginning we just built all of this big smart contract system, which manages the permissions of devices and booking, renting, selling, everything. And now we say, well, you cannot reasonably release this beast to the public chain because it just doesn't work because of scalability. So that's why we're looking into state channels heavily, but also into a quick solution is, of course, doing a proof of authority chain with a parity bridge to the main chain. There are, of course, many reasons why I don't like the solution, because the interoperability between the application is just not given. You create your own little mini ecosystem by having your private chain, and just the bridge just gives you control of tokens or ether from the main chain into your own proof of authority chain. But that doesn't give you any interoperability between the different applications on the public Ethereum chain. So it is a quick solution to get going, but it's not where we want to end. So really hope for Plasma and sharding to take off. That's my current hope. If it doesn't come, then this would mean we just build tons of private chains and try to connect them to each other, what Polkadot is also trying to do. Polkadot will be a solution for connecting those chains, which is also okay. So, and because of those scalability reasons, we have not put a lot of money into marketing because it wouldn't make sense to scale up the business when the infrastructure is not ready for it. That's why we are working more on getting technically ready for this. We are working on having very, very thin clients on simple IoT devices where you cannot even run a light client on them. So we're working on a protocol and a paper which will come out soon. So we are doing more theoretical and infrastructure work, enabling the business case theoretically, but have not taken off from a business side of things, except of our consulting projects where we just get paid for. So that's where we stand right now. But if you want to test it, you can go to mvp.slock.it and register as a tester, download the app, and see what you can do with it already.
So I think is the protocol that you're referring to the Universal Sharing Network?
That's how we framed this. Universal Sharing Network means a network of devices which you can pay to access using the blockchain as a backend. That's what this is. And this is a lot of different things. And that's why it's called universal. But yes, so I would say our app is an user interface to this universal sharing network.
Got it. So another project that you've worked on with Slock.it is Share and Charge. Can you talk about your experience with that project?
Yes, this was a company called Energy coming to us asking for technical help. And we helped them to implement a use case for people to share their charging stations. So if you buy an electric car, usually you also buy a charging station, which is not used most of the day. And we connected those charging stations to the blockchain, integrated it within their user interface. And so there people could say, I see all those private charging stations now and could go to them. And those people who own them can make some money with it. So it was also a project where we connected those devices, in this case charging stations, with the blockchain, and then also connecting it to the user interface they are having. This was a very interesting project. And it was not our project. We did it for someone else. But it was still very fun to work with this team and seeing real objects like cars using this public Ethereum chain in real life. And what I think was one of the first applications where a large corporation was giving their assets or offering their assets on the public Ethereum chain and normal people using it without even knowing that there's a blockchain behind. So this was very interesting and a good experience.
So when you're putting cars or charging stations on the blockchain, do you have to create custom hardware for them to integrate with their car or their charging station?
We don't have to, but we would like to. So we have built a Raspberry Pi solution, but we also have built an Arctic. Samsung Arctic is another IoT platform solution. where ideally you integrate this within the device and are running at your own light client. This, of course, is the best way of doing it. Often this is just not feasible. And that's why they're using remote clients or a cloud API, which of course means the device itself doesn't get any added security. You just have a way of controlling the device over the blockchain, but a cloud reads the data and then the cloud sends the information to the device to switch on or off. So to get going quickly, it's okay to basically go with a remote client connecting to the cloud. But for real security, we need a better solution. That's what we are working on actually right now within the company, to releasing a protocol, how to cheaply, without synchronization time and a lot of bandwidth, how to connect an IoT device to the blockchain. But I just can give you this teaser basically, but you will see it when it's online on a blog post.
Okay. What are the other projects in the Ethereum space that you're excited about right now?
So I'm excited about all those governance projects such as Aragon and Colony. I think that's a very good use case for Ethereum, doing governance on it. I'm very excited on those state channel work, which is done by L4 and by the Raiden team. This is exciting infrastructure which is being built right now. Less excited about ICOs, but that's clear. But those are the things where I think Ethereum will have a huge impact on governance and, in my view, of course, IoT payments. I do not see it as a currency where normal average people will use it, maybe, but that's not the intent of Ethereum at least. But those are the applications at least which interest me the most right now.
Okay. Well, Christoph, I want to thank you for coming on Software Engineering Daily. It's been great talking to you about Slock.it and the DAO, and of course, your reflections on those events is much appreciated.
Thank you very much for having me.
We are running an experiment to find out if Software Engineering Daily listeners are above average engineers. At triplebyte.com/sedaily, you can take a quiz to help us gather data. I took the quiz and it covered a wide range of topics: general programming ability, a little security, a little system design. It was a nice short test to measure how my practical engineering skills have changed since I started this podcast. I will admit, although I've gotten better at talking about software engineering, I have definitely gotten worse at actually writing code and doing software engineering myself. But if you want to check out that quiz yourself and help us gather data, you can take that quiz at triplebyte.com/sedaily. And in a few weeks, we're going to take a look at the results and we're going to find out if SE Daily listeners are above average. And if you're looking for a job, TripleByte is a great place to start your search, fast-tracking you at hundreds of top tech companies. TripleByte takes engineers seriously and does not waste their time. I recommend checking it out at triplebyte.com/sedaily. That's triplebyte.com/sedaily. Thank you, TripleByte, for being a sponsor.
Wow.